We fantasize about finding far-off universes, spilling over with rich vegetation and life very much like here on Earth. The James Webb Space Telescope has now found a genuine atmosphere on a far-off super-Earth. Interestingly, we could be well on our way to finally exploring a world like our own in the depths of space. However, 55 Cancri presents specialists with a riddle. This exoplanet, which is just 41 light-years from Earth, sometimes appears as a super-Earth and sometimes as a hostile heater. So which is true? The James Webb Telescope has made several surprising discoveries in the search for answers to these inquiries. Scientists are utilizing NASA's new JWST to investigate the Earth-like planet 55 Cancri with the help of this remarkable technology. This exoplanet is a direct neighbor of Earth and has amazed researchers over and over since its revelation in 2011. Initially, the planet appeared to be a hot yet rocky world that might have an atmosphere. But then researchers found stunning new data about this planet, using Webb's unique methods of investigation. Scientists aim to unravel the mystery surrounding this strange planet, and they succeeded. The results are astounding. The study chief, Renu Hugh from NASA's Jet Propulsion Laboratory, was excited about the James Webb Telescope, stating, "We are now entering a totally new aspect of science. For the first time, we know exactly what is happening around the exoplanets, and we can even get our initial impressions of the planet's surface." 55 Cancri, the very hot super-Earth, presents an intriguing paradox. Typically, planets that offer better living conditions than our own are called super-Earths. Generally, such planets are somewhat larger, denser, and hotter, and their stars have a longer lifespan than our Sun. The first 2 points apply to 55 Cancri. For years, we knew the size of the planet, its orbit, and its approximate density. However, we had no substantial data on its atmosphere, and the temperatures were merely estimates. Never before in the history of cosmology have we been able to study planets outside our solar system with such accuracy and detail. Webb spectrometers can not only identify water in a planet's atmosphere, but also gases like methane, carbon dioxide, and other volatile compounds. The more similar the atmospheric data of the planet is to the values of our Earth, the more confident we are that we have found a genuine super-Earth. 55 Cancri is one of 5 known Earth-like planets orbiting the Sun-like star 55 Cancri. With a diameter twice that of Earth and a higher density, the planet was previously categorized as a super-Earth. Earlier investigations yielded puzzlingly inconsistent data. For instance, studies by the Spitzer Space Telescope showed that the planet orbits its stars so closely that its surface is likely less rocky and more molten. Moreover, the planet's orbit is probably tidally locked, with a day side and a night side. This so-called super-Earth could be a scorching hot spot that neither harbors an atmosphere nor supports life. Scientists have repeatedly studied this puzzling world, and experts from the University of New Mexico have now investigated 55 Cancri closely for over 10 years. Researchers described it as downright baffling that none of the observations had yielded clear results until now. The new telescope should finally shed light on the darkness and reveal the mysteries of this planet. Is it feasible for a planet to have 2 atmospheres? Yes. 55 Cancri once had an atmosphere that was then stripped away by its star. It's nearly unfathomable. But this variable planet essentially developed another atmosphere. The spectroscopic analysis astonished researchers. They had never had such detailed and extensive data on this planet before. Using the latest information, the scientists were able to accurately reconstruct the history of 55 Cancri's climate, and it is genuinely unusual. Due to its extreme proximity to its star, surface temperatures of around 2,400 degrees Celsius have literally scorched its protective shell. However, this exoplanet performed a miracle and effectively replaced its original atmosphere of hydrogen and helium with a new one. This secondary atmosphere was formed in a remarkable manner through outgassing from the planet's rocky interior. It was likely the high temperature at 55 Cancri that caused a new atmosphere to form. However, the new atmosphere is quite different and primarily consists of carbon dioxide and carbon monoxide. You might wonder how the JWST can identify such details. The light that reaches us from 55 Cancri is so faint that Webb would never take a direct picture of this planet. However, the telescope can measure minute changes in the system's light as the planet orbits its star. The data from the MIRI instrument show the 55 Cancri system's brightness diminishing as the rocky planet 55 Cancri moves behind its star. Researchers refer to this phenomenon as a secondary eclipse. The graphs from the investigation show a secondary eclipse light curve during a secondary eclipse. The light reflected or emitted by the planet is obscured, allowing only the light from the star to be measured. By comparing the brightness before and during the eclipse, the total light coming from the planet can be isolated and analyzed. The data shows a clear drop in brightness caused by the planet's emissions. Interestingly, the emissions reveal that the temperature on the day side of the planet is about 1,540 degrees Celsius, which is much lower than expected and indicates an unusual, rich atmosphere that distributes energy from the day side to the night side. It sounds insane. However, past information from NASA's presently outdated Spitzer Space Telescope has repeatedly demonstrated the presence of a climate with indications of oxygen, nitrogen, and carbon dioxide. These could be biomarkers and proof of life. Yet, how might it be that a planet with such outrageous surface temperatures shows hints of biomarkers in its environment? Planetary scientist Hugh explained in his article in the journal Nature that 55 Cancri even showed marks of metallic substances and elements, such as silicon, iron, aluminum, and calcium. Anyway, the temperatures are so high that researchers suspect the source of these traces could be a thin cloak of disintegrated rock. This raises the thrilling question of whether this planet was once cooler and harbored organic life. We know from our own solar system that planets have traded positions within the framework over millions of years. It's conceivable that the rocky world 55 Cancri was once in a habitable zone and later moved into an orbit that brought it closer to its star, resulting in the overwhelming temperatures. Our Mercury is also being pushed further toward the Sun by Jupiter, and some analysts believe that Mercury was once in an orbit further away from the Sun. It may be the case that there was once life on 55 Cancri. The exoplanet appears increasingly like a world of obvious contrast, a planet that has undergone fierce changes. This is shown not only by its bound orbit, but, most importantly, by the problematic measurement results from various telescopes. The first sign of an impressive climate came from temperature estimates based on the warm emissions of this world. If the exoplanet is truly covered by dim, liquid stone and a meager shroud of disintegrated rock, the day side ought to be around 2,200 degrees Celsius. However, Webb's data showed a temperature of only 1,540 degrees Celsius. This might be because the energy is well distributed by thermal processes between the cool night side and the hot day side. Magma flows transfer heat to the night side, where it is lost and cooled. However, simulations showed that this effect alone isn't enough to explain the much lower temperature. When the research team analyzed further data from nearby observations, they uncovered signs of an unstable but rich environment. This does not fit with a planet made of disintegrated rock. The team, led by planetary researcher Hugh, has reached the conclusion that 55 Cancri has some unique component that must relate to the release of gases from its interior. Thanks to Webb, investigation into this thrilling planet has made considerable progress, but we are still a long way from definitive evidence of life in space. Are you captivated by such significant discoveries about 55 Cancri, or are you one of those people who would be much more appreciative if we could finally prove the existence of genuine extraterrestrial life in space? Even if we have not yet succeeded in providing definitive proof, the James Webb Space Telescope has brought us closer to this objective than ever before. Moreover, its extensive range and sharpness offer us the opportunity to explore exoplanets for the first time. Although some of these planets are enormous, they are minuscule objects compared to the vastness of the universe. For quite a while, tracking them down was like searching for a needle in an almost endless haystack. We now know about more than 5,000 exoplanets, which is a lot for our science, but estimated against the actual number of planets, it's not even a modest handful. The specific number of Earth-like planets is constantly changing. Up to this point, we have a couple dozen candidates that have the potential to be Earth-like. Webb is now tasked with clarifying which planets are truly Earth-like and which are not. Proxima Centauri B has often been named the most Earth-like planet. This planet, which is just 4 light-years away, orbits the star nearest to us and lies in the habitable zone, where conditions for liquid water are ideal. Our hopes of finding life there dimmed after the star Proxima Centauri directed fierce flares at its planet. After this setback, attention shifted to other significant contenders, such as Kepler 452b and TRAPPIST-1e. Webb was able to confirm the presence of Earth-like planets in the TRAPPIST system, but individual examinations are still inadequate regarding the star. TRAPPIST-1 likely has 7 planets orbiting it, 5 of which are similar to our Earth. Kepler 452b is currently the most Earth-like planet ever found in space. It is around 6 billion years old and slightly larger than our home planet. Here, too, we currently know nothing about its atmosphere or signs of biomarkers in the environment. We will need to wait until Webb thoroughly analyzes this world. Click subscribe now and anticipate many new astonishing discoveries.